This is the final project presentation, deliverable 4 for the HigherFHIR group, identification of patients requiring statin therapy. The U.S. Preventive Services Task Force recommends that adults without a history of cardiovascular disease use a low to moderate dose statin for the prevention of cardiovascular events and mortality when certain conditions are met. Every day, providers see many patients who each have different existing conditions, and providers may be focused on those current conditions or illnesses. Prevention can be easily overlooked. By leveraging CDS hooks on HigherFHIR, we can automatically check conditions upon chart opening and provide the physician with an indication that a patient would or would not benefit from statin use. This takes the burden off the physician and greatly benefits the patient. Before looking at the solution, let's first take a look at the development process. First, we gathered user requirements from multiple sources, including the assignment sheet, our mentor, Dr. Duke, and external research. We researched requirements and determined mandatory and optional features, researched tools and data sets, created a software architecture plan, iterated through the software development process, which included initially developing the architecture, followed by a data model, followed by development and research iterations, and finally deployed through using Jenkins and Docker. After development was complete, we went through a cycle of quality control to ensure that the final application had no known issues. This project utilizes a very modern technology stack. On the front end, we used HTML, CSS, and a library called Bootstrap, which employs a very common and consistent look and feel across the interface. There's quite a few modern websites that use this, such as Twitter, and it's supported by the jQuery framework for communication with the backend code. On the backend, we utilize Spring Boot and Java to communicate with the services via REST. The database is an instance of Postgres hosted by the Georgia Tech Institute of Technology. The data is served in a HigherFHIR format. One of the fundamental technologies underlying this project was the use of CDS hooks for the purpose of providing recommendations via cards. Looking back, the technology itself was very straightforward. However, as with many newer technologies, there was a learning curve. After several communications with Josh Mandel, the lead architect for the Smart Health IT and one of the creators of CDS hooks, as well as several other community members, we were able to get our services integrated into the public sandbox. Our lesson to be learned: adherence to the specification is critical. Research was done in multiple phases to facilitate an iterative approach to development. We looked into CDS hooks and leveraged its sandbox. We did some heavy reading on statin and the conditions that could be indications for its usage. For example, we had to be familiar with the health cholesterol levels. We had to figure out how to calculate the 10-year risk of a cardiovascular event. This was a challenging task.
Hi, my name is Tucker Vason, and I will continue with the presentation. For the deployment portion of this project with Jenkins and Docker, the Java code was built using Apache Maven. In order to prepare for deployment and prevent errors, the Docker container was tested locally. The application makes use of a single Docker container for all of the functions. The Docker file uses a multi-stage build and successfully rebuilds and deploys after each new commit to the GitHub repository. And the application is viewable via the Georgia Tech virtual private network here. And as you can see here, the Jenkins dashboard shows the commits to the project repository, the build, testing, and deployment status, and durations for each new build. Now I will walk through a quick demo of the application's custom front end. This is the home page for the application. It provides a brief description of the project and a link to the services page to get started. The services page is where the primary functionality can be accessed. It includes a single input field here where the healthcare provider can search by the patient's ID, and the application will return information about the patient as well as a therapy alert specifying whether or not statin therapy is recommended. Also, under patient information, A brief justification for the recommendation is provided. So, for example, if I was a physician and would like to obtain a statin recommendation for patient ID 746, I would enter 746 here and click search. The available patient information is displayed here. Below, the therapy alert is shown, which as you can see indicates that statin treatment should not be recommended to the patient. The justification provided here shows that the patient is already under statin treatment, therefore recommending statins is unnecessary. The web front end uses jQuery AJAX to send requests to the application for patient data and statin recommendations. The application returns the patient data from the database and performs the risk calculation to determine if statin will be recommended for the patient. The website, as shown in the demo, gives basic information about the group and project. The application front end is extremely simple and behaves much like Google.com with a simple text entry field and search button. For this project, the customer required an application that would identify when a patient was in need of statin therapy. It was requested that upon patient chart opening and leveraging CDS hooks in HigherFHIR, we did the necessary lookup to calculate if statin was recommended or not based on the implementation guide for statin recommendation. Once the card was returned with a recommendation, the link should be provided for the physician to see the reasoning behind the recommendation. For the project development documentation, a markdown file was created in the GitHub repository. The file contains instructions for integrating and testing the application with CDS hooks, testing the application in a Docker container on a local machine, and viewing the CDS hooks card that would be shown to a physician using an EHR. For this application, it was determined that extensive user documentation was not required. As shown in the demo, the front end of our application includes instructions for the user on the services page. The interface is simple, clean, intuitive, and self-explanatory for any healthcare provider. The CDS hooks card links directly to the application. This is a snapshot of the CDS hooks card that would be shown to a physician using an EHR. It is very simple and provides the statin recommendation and link to the application so the user can learn more. The custom web user interface uses HTML and CSS with the Bootstrap library for styles. Here's a snapshot of the overall project status. The CDS hooks functionality is implemented and tested. The patient data retrieval core functionality has been completed. The statin calculator risk calculation algorithm has been implemented and most corner cases are addressed. The user interface is complete. It's integrated with the backend code and properly displaying CDS hooks cards and patient information. For DevOps, the application is deployed with Jenkins. It is accessible via the Georgia Tech Virtual Private Network at the URL displayed here. This is the Gantt chart for weeks 11 through 15. The Gantt chart was created in Google Sheets, and a complete view of the chart can be seen at this link. As you can see, most of the tasks associated with the development of the application were completed by the end of week 14. And finally, here are the references used for this presentation.